An automatic purger or auto-purger operates on the same principles as the refrigerated purger with one significant difference. The entire process is automated. An auto-purger therefore reduces the risks associated with line breaks while simultaneously removing non-condensable gases. This makes them highly attractive in ammonia refrigeration system design. Auto-purgers are capable of handling multiple purge points. A typical auto-purger can be connected to as few as 4 or as many as 24 locations in a system. While the operation is automatic, it is important that an operator monitor the unit for proper operation on a regular basis. The number of purge cycles should be regularly observed, since this serves as an indicator that air may be leaking into the system. There are many variations in auto-purger design, but key features typically include a foul gas connection, a high-pressure liquid connection, suction line connection, float switch, liquid drainer, air separator chamber, evaporator chamber with a condensing coil, and a water bubbler. When placed in operation, the auto-purger enters a cooling stage. In this stage, the liquid feed solenoid valve energizes, which allows liquid ammonia to pass through the liquid feed valve and fill the evaporator chamber at the bottom of the liquid drainer. As the purger cools, some of the liquid will evaporate and collect at the top of the evaporator chamber, where it is returned to the wet suction header in the system. Simultaneously, liquid ammonia fills the float chamber and air separator. There is a 30 psid check valve in the line that connects to the air separator chamber. The liquid in the air separator chamber is cooled by the cold liquid ammonia in the evaporator chamber. The flash gas formed as the liquid expands across the check valve collects in the float chamber, where it is returned to the evaporator chamber through the vent solenoid valve. The returned vapor is condensed in the evaporator. Filling the float chamber causes the ball float to rise. The float switch is interlocked with the vent solenoid valve to de-energize the valve when the ball reaches a predetermined height. Once the temperature sensor attached to the evaporator chamber reaches approximately 20 degrees Fahrenheit, the purger will transition from the cooling stage to automatic, and the unit begins to collect non-condensable gases. Once in automatic mode, the foul gas and liquid metering solenoid valves are energized. The foul gas solenoid valve allows a mixture of non-condensable gas and liquid ammonia to enter the coil inside the evaporator chamber. Condensed refrigerant is recovered through the liquid metering solenoid valve. Liquid in the foul gas line is allowed to collect in the liquid drainer, where it is supplied to the evaporator chamber. Any ammonia vapor condenses in the evaporator coil. The mixture of non-condensable gas and liquid refrigerant flows through a check valve into the air separator chamber. Non-condensable gases collect at the top of the float chamber. The accumulation of non-condensable gases causes a ball float to drop. Once it reaches the switch setting, the auto-purger begins the purge cycle. During a purge cycle, the purge gas solenoid valve is energized, which allows the accumulated non-condensable gases to flow into the water bubbler. At the same time, the water makeup solenoid valve is energized, which introduces fresh water into the bubbler. Any residual ammonia is absorbed by the water. Ammonia-laden water is flushed down the drain through the overflow tube. As air is purged, the level in the float chamber drops, which ends the purge cycle, and the purger resumes collecting non-condensable gases.